Okay, in this video we will talk about one of the basic ensemble learning algorithms called bagging and pasting. Okay, so without wasting time, let us first see what does this two algorithm means. So basically, if you remember from my previous videos, we get a fair idea about what ensemble learning is, right? And in last video we talked about the AUC and the ROC curve, right? So with all those knowledges, we will try to go deeper into the different ensemble learning algorithms. So the basic one will start with bagging and pasting, then we'll definitely move to other ensemble learning algorithm like our add a boost, random forest, and those stuff. Okay, so what is bagging? So bagging, or basically the name comes from, actually, is the bootstrap aggregation. So if you remember, when I talked about the bootstrap in, I think two videos back, over there we have seen what bootstrap is, right? And the core idea behind a bootstrap is we are doing the sampling with replacement, right? So the bagging algorithm is basically direct implementation of this bootstrap approach. So bagging or bootstrap aggregation is one of the earliest and most intuitive and most simplest ensemble learning algorithm. Okay, so here the main point is, like, over here will be basically the diverse, because in any ensemble method you choose, the diversity of the classifier is the important point over here, right? We are basically using more than one classifier and then aggregating their output, right? So in bagging, the diversity of classifier is obtained by using the bootstrap, or basically which is the sampling with replacement replicas of the training data. That means from the training data we'll basically creating smaller data sets with replacement. We see an visualization as well in the next slide. Okay, then we will be using those training set for the training purpose, so those subsets for the training purpose. Okay, so now each training data subset is used to train a different classifier of the same type. So this is important over here. In bagging, the classifier we will be using is all or in the same type. Okay, so that's the main thing over here. But the training data we will be creating, the training subsets we'll be creating, that is going to be created by this bootstrap method. Okay, so that's basically contributing to the diversity here. Now individual classifiers are then combined by taking a simple majority vote. So this is the combination part, right? So the majority vote is used for classification problem. So when we'll be using this bagging method in the classification problem, we'll be using the majority vote. We'll see an example as well in next slide, and as well as today we'll be working on a data set, so we'll be seeing a live example as well over there. Okay, and if we talk about the regression problem, so it's generally we use average of the outputs of the different classifier over there. Okay, now we talked about bagging. Now when we do the sampling with replacement, it is bagging, but when we do the sampling without replacement, it is called our pasting. Okay, so that's the difference between these two algorithms. Now when we'll see in scikit-learn, so it's just a method parameter which will be changing, which will make a bagging classifier a pasting classifier. Okay, now let us try to visualize it, how bagging works. So for that, let's say we have this sample data set. Okay, so as we said, bagging is a sampling with replacement, right? So from this particular data set, we can create sample something like this one with replacement. Let's say our sample size is 3. Okay, so we could have created a sample of something like this one. If you see, the first one we picked up as red, right? Then we give it back to the main data set. Then we are again picking up yellow, right? Then yellow we are giving it back again, because we are sampling with replacement over here, right? Again, if we pick up, it is possible that yellow will come up again, right? So this could be one of the data set, right? Now similarly, we can have data set something like this one as well, right? Where all of these samples are different over here, right? or again we can have something like this one, or two red and one violet over here, right? So similarly from here as well, right? So this is the basic idea behind sampling with replacement, right? So now we can create multiple training sets based on our need, right? So then what we can do is, for all of this training data set, what we will do, we will use a single classifier, same type. So this is important over here. So if you are choosing a logistic regression model, your all models will be logistic regression over here. That's why I use this similar gear alignments over here. Okay, so now if you see what happened when we try to test this particular model on a new data set, so what will happen for each of these classifiers over here, right? They will classify according to their whatever data they have trained and whatever classifier we are building it over here, right? So according to that, it will just classify this new data set, right? So the first one may be classified as correctly as yellow, second one may be classifying as correctly as yellow as well, but the third one may classify it as red, right? Now because all of these classifiers are classified based on basically created based on different training data, right? So now what will happen, so from all these classifiers we get the classifications, right? Now we'll take the majority vote over here, right? That means which were the new classification which is coming most over here. So that's called majority vote, which is nothing but yellow over here, right? So when we'll do the aggregation, so our final classification will be yellow over here. So that's the concept behind a bagging. Okay, so now if you see like this whole stuff, right? Now bagging is different with pasting is only over here. Okay, when we do the sampling, we'll be doing the sampling without replacement over there. Okay, now there is another concept. If you remember from my bootstrap video over there, what we have discussed is like there is a concept called out of bag data points as well, right? Or samples as well. So whenever we create a particular training set, right, from the actual training set, so the samples we have selected, right? So here we have selected the red and yellow one, right? The other samples like the green one, the orange one and the violet one over here, right? These are called the out of bag samples. Now these samples you can use to test the individual classifier over here as well. Okay, so that will get an estimate of how this classifier is performing over there. Okay, now if I just talk about pasting, as I said, we will start with similar kind of data set over here, right? Similar sample size. But over here, if you see the samples we are choosing it over here, none of the things are repeating over here because we are doing sample without the replacement over here. Okay, so whatever the data sets we will be creating, subsets we will be creating, everywhere we will have a separate stuff over here, right? So then the ultimate concept is same. So we will be using the same classifier over here, similar type of classifier over here. And when we'll have a new data point, so each and every classifier will have their own classification, and based on that we'll be using the majority vote for the classification problem, or we'll be using the average one for the regression problem to get the final, either final classification or the final prediction over there, right? Now let's work on a wine data set which I just introduced in my AUC and ROC curve, and see how we can use this particular concepts using a scikit-learn. So we will be using a scikit-learn library. So let's do that one. Okay, so for today, for bagging, we will be using this wine quality dataset as I mentioned before. Okay, so this dataset I have downloaded from this UCI machine learning repository. So I will be giving this particular link in my video description as well, so that you can download this data from here. Also, I think this particular dataset is available in Kaggle as well, so you can download it from there as well. Okay, so if I just show you the data today I have. So let me show you the data. So it's basically a normal wine data. It's basically red wine data. Now for different features like acidity, the volatile acidity, citric acid, residual sugar, basically there is a field called quality over here, right? So based on these factors, our job is to predict this quality. Now to make this particular, if you see it over here, this quality is from 1 to 10 in that scale, right? So to make this particular problem from a multi-class classification to a binary class classification, what we'll do is we'll assume that, like, if the wine quality is greater than equals to 7, it's a good wine, otherwise it's a bad wine. Okay, so accordingly we will be creating a new feature over here which will basically hold that particular value. Okay, we'll see how to do it as well, but that's the basic assumption we will start with. Okay, now to read this particular data, we will use scikit-learn and pandas module. Okay, now we'll be using spider for our development purpose, but you can use any of the Python environment over here, whatever you have. Okay, so initially what we'll do is we will just import pandas as PD. Okay, now pandas provide a module called a function called read CSV. Okay, so we'll use that one to read the CSV file. Okay, so now here it basically looks for the file path over here. Okay, so we'll be giving the absolute path, whatever we have it here. Okay, we'll give that one. Then we have to give the file name as well, which is nothing but winequality.read.csv. correct? So we'll give that one. Now as I am using Windows and I am giving a absolute path, I have to escape this one, this slashes over here. Okay, so this is our wine data, right? Now let us try to see first whether we have successfully read that file or not. So for that we'll do this one. Okay, import import. Okay, save it. So if I just print the data over here as well. Okay, so let us try to see whether we have successfully read that file or not. Okay, we are able to read that file over here. Now the thing is that we have to create that extra category column, right, which will basically define based on this quality column, right? So that whenever the wine quality is greater than equals to 7, we'll make it as good or something, or make it as 1 or 0. It does not matter, because at the end of the day we are trying to basically convert this particular problem as two classification problem, right? If you make this problem as a multi-class classification problem, this is also fine, but we'll see in future videos as well how to work with multi-class classification problem. Okay, now what we'll do first, so that's why we will create this category column over here. Okay, so we'll say wine data category. So this is how we will be adding this new column over here. Okay, now what will be the category? So it will be whenever we will have this quality column having greater than equals to value of 7. Okay, so this expression will basically return me as true and false, right? If you see it, if you print this one over here. Okay, so if you see the category column, we will be having only the true false value over here. We'll convert it to 1 and 0 using a numpy method very shortly now. Okay, so now we have to choose our x and our y values, right? So this will be this x values we'll be using for our training purpose, and y value we'll be using for the prediction purpose, right? So if you just closely see the data over here, let me just reopen this file again. Okay, so the first 11 columns over here from A to K, right? So this will be basically our testing data, right? So if I just expand it, so from A to K it will be our testing data, and instead of predicting the quality, we'll be predicting a new field called category over here. Okay, so we will just do that one. So what will be our X? It will be wine data. wine data, and we will be choosing the first 11 column over here. That means wine data dot columns, right? And we will be giving 0:11 over here, right? And this dot values we will be choosing for our x, and what will be our y value over here? Y value will be wine data dot category column, right? Dot values over here. Okay, then as I said, from true false we'll be making it as 0 or 1. So for that we'll be using the as type method of numpy over here. Okay, dot as type, so numpy dot int, so we'll be converting it to int. So for that we need to import numpy as np over here. Okay, so we got our x data values, we got our y data values over here, right? So now we need to basically convert or basically select our test data and the training data from this whole data set, right? So for that scikit-learn provides a module called test train split. Okay, so we'll be using that one now. So if I just go to scikit-learn website and search for train test split over here, okay, so this is defined under sklearn dot model selection dot train test split. Okay, now this is expecting number of arrays over here, which is nothing but our x and y values. Then you can give the test size either in fixed size, or you can give a percentage as well. Accordingly it will pick up the values randomly from your picked up the samples basically randomly from your test data. You can give the train size as well. Now you can give a random state, which is nothing but an integer, which will act as a seed when this random number generator will be picking up random samples, right? So this random underscore state will be integer value will be act as a seed for that random number generator over here. Okay, so and this particular method returns a lot of stuff over here. Okay, so it basically returns the train. That means what will be the for the training x values, what will be the testing x values, what will be the training y values, and what will be the testing y values over here. Okay, now to use this one we have to import this guy, so we will be importing this one now. Okay, so from sklearn model selection import train test split. Now what we'll have, we will get these 4 values over here, so we will just copy this one. Correct. Now in the train test split we'll be passing our x, which we have defined it over here. We'll be passing our y, which we have defined in line number 8, right? Now in the test size we'll be providing, let's say 30%. Test underscore size we will be providing, let's say 0.30. Okay, so this is 30% data we will be randomly choosing from our wine data set to make it as test data set. Okay, and the random state will be using, let's say any number, you can use it over here. Let's say we'll be using random underscore state, we'll be using, let's say 40 or 41, whatever, some number you can use it over here. Okay, so this will become our training data set. So what is it saying? It is saying invalid syntax over here. Okay, so we have to give an equals to over here. Okay, so we created our training and test data set over here. Okay, so if I just print it, let me just show you a couple of stuff over here. Let's say if you just want to print the size of the training data set of x, you can print something like x underscore train dot shape. Okay, it will give an idea about how many records basically you are selecting from your actual data set to make it as test data set, or basically training data set over here, right? So whatever the test size, list the other 70% we'll be using for the training data set over here. That means out of, if I just see it over here, out of 1600 we are using 11119 records for our training purpose. Rest of the data we'll be using for our testing purpose over here. Okay, now in machine learning, this is really important when you work with data set which is numeric in nature. So you basically convert, or when in my channel I still not discuss those concepts related to dimensionality reduction, which is nothing but it basically make all these features into a same scaling. Okay, so in future we'll be definitely looking into those dimensionality reduction concepts as well, but for now, just to go by, when you work with numeric data set over here, we will make it as same scale so that it will follow a normal distribution for all the features over here. Okay, now for that there is a method in scikit-learn called standard scaler. Okay, so let us try to search that standard scaler over here. Okay, so it is defined under sklearn dot preprocessing dot standard scaler. Okay, if you see the documentation over here, it standardized the features by removing the mean and scaling into unit variance over here. Okay, we'll see in future videos very deeply in all of these concepts over here. Now this particular method, this particular module supports a lot of methods over here. Okay, now this is called like fit transform, get params, those stuff. So today we'll be using the fit transform method over here. Okay, which is like fit to data and then just transform it. So it basically accepts the x values and y values and some parameters over here. Okay, so let us try to see that one first. So for that, what we will do it today first is we'll say scalar underscore, we'll just give it a name dear for dimensionality reduction over here. Okay, so this is, first we have to import it, so I'll just copy it from here, from sklearn dot preprocessing standard scaler. Okay, so first we have to create an object of this class. Okay, now then we have to transform it. So I'll just say x underscore train. So we will be basically transforming this stuff over here. Okay, and then we'll say transformed version, transformed equals to this guy dot transform fit transform. There is a method as I shown you over here. Okay, so it's basically takes our x values, so the value we want to transform it over here. Okay, so this is for the training data set of x values, right? Now similarly we have to do this one for the test data set as well. But before that, let's try to fit this particular data into a normal logistic regression model and see its performance. Then what we'll do is we will create that our bagging model and see if there is any performance improvement it is doing compared to a single logistic regression model over there. Okay, so for that we have to use, let's say we'll be using today the scikit-learn logistic regression model as well only. Okay, so for that we'll just search logistic regression over here. Okay, so this is the model we'll be using today, scikit-learn dot linear model dot logistic regression over here. Okay, so the import we have to do it something like this one, from scikit-learn dot linear model import logistic regression. Okay, so we'll go over here, we'll import it. Okay, then our logistic regression model will be, so let's say logistic regression model. So this will be this logistic regression. Then if you see the documentation over here, okay, it needs to give, you need to give a solver over here. You need to give a solver over here. Okay, so I'll be giving this LBFGS, so LVER equals to this one. Okay, so this is our logistic regression model over here. Now as initially we will be using a single model because we want to compare it. So then first we will fit that model and try to see performance of this model by measuring that AUC over here. Okay, we'll be drawing a ROC graph over here as well. We'll just fit the model now. Okay, so this one, there is a method called fit over here which requires the x value as well as the y value over here. Right now the x value is our transform value over here, right, and the y value is our this one. Okay, so now we will just do the prediction. Now we have already fit the model over here, right? Now before prediction, basically we have to convert this test to transformed as well, right? So we'll just transform it equals to this scalar here dot transform, then we will just pass this x test over here. Okay, now what we'll do, we will just predict it. We'll say y underscore prediction, okay, equals to this model dot predict. Okay, and what will be the prediction value? We have to pass the test dataset over here. Okay, so this is nothing but our transformed test dataset over here. Okay, so we successfully created a logistic regression model and fit the data over here. Right now, just to know how this model is performing, if you remember from my previous video on UC and ROC curve, we, apart from different false positive rate, true positive rate, we talked about the prediction and accuracy as well over there, right? So you can easily determine the prediction and accuracy score using this scikit-learn prediction underscore score method and accuracy underscore score method as well. Okay, so if I just print them, print the prediction score, basically precision score, so it will be nothing but our, so there is a method called precision underscore score, okay, and which basically takes the test value and the predicted value over here. Okay, so that means our y underscore test, okay, and the y underscore predicted, right, the actual value and the predicted value over here. Now precision underscore score, if I just search over here in scikit-learn, okay, it is defined under sklearn.matrices, then precision underscore score. Okay, so we will try to do the similar import over here. Okay, so we'll copy this one, we will paste it over here. So this will be our precision score. So if I just try to run it now, so let's not run this guy over here. Okay, so it will be comma over here. So now if I just try to print this precision score over here, it is like 72% it is coming up, right? So similarly you can print the accuracy score over here as well, right? So accuracy means overall the test data set wise how much it is predicting correctly, right? That's the accuracy score over here, right? So if I just search it over here, the accuracy score, okay, so it is defined under sklearn.matrices.accuracy score, the similar way we have imported for the precision score. So you will be importing this one over here. Okay, so we'll be using the accuracy score here and we'll be passing the same value, the test value, the actual test value and the predicted value over here, right? So accuracy score, so it will be accuracy score over here. Okay, so let's print that one. So accuracy, we are coming up as around 88.9% over here. Okay, now let's draw the ROC curve and determine its AUC, which is basically, as I told in my previous video, it's a measurement of how the model is performing over here, right? So let's do that one. Now there is a method called ROC underscore curve in scikit-learn, okay, which basically gives you all the necessary details required for the ROC curve. Basically it basically returns the false positive rate and the true positive rate which is required to draw a ROC curve. Okay, now what it requires, basically it requires the actual y values, that means that the true binary levels over here. Okay, now it also requires a probability y score over here. If you see, this is the target score. It can be either probability estimates or of the positive class, or confidence values, or non-thresholded measure of the decisions. So for each and every class values, what is its probability, so that thing it also requires over here, and it basically give you the FPR, the TPR, and the threshold value over here. Okay, so for that, first we have to import this one, right? So from sklearn, so what I'll do is we'll just copy this one. We'll say from sklearn dot matrices, okay, import ROC curve over here. Okay, so this ROC underscore curve, so this will be our ROC curve, and as it requires the arguments, so we will be constructing this arguments over here. Now it's basically giving me three values over here, right? So FPR, TPR, and then threshold, right? So this thing, that means here I'll be giving my ROC curve. Okay, now in ROC curve, as I said, we need to provide the true y values, that means y test values over here, right, and some probability values. Okay, we'll name it as probability vals. So this one we will be constructing probability val equals to, so we will be constructing using the predict proba function, okay, for this particular logistic regression. Now not all the machine learning models supports this particular predict underscore proba functions over here, but as logistic regression do that one, so we will be calculating this probability values using this model, okay, dot predict proba. Okay, so now this predict proba method will be passing this test x values over here. Okay, test x values over here, and we will be getting this one. Okay, okay, so we got our FPR, TPR, and threshold values over here, right? Now let us try to draw this ROC curve over here. Okay, so for that we'll be using the matplotlib. So import matplotlib dot pyplot, okay, as PLT, let's say. Okay, so this particular module will be using as to draw the plots over here. Okay, so first we will just try to do it quickly. So we will say plot dot subplots. So subplots, we have to give a size over here. Okay, so figure size, we'll just give let's say 8 by 6 over here. Okay, 8,6 over here. Now plt dot plot, so what we'll be plotting, as our ROC curve is FPR over TPR over here, right? So we'll just do this one, right? Now, if you remember from my previous video when we talked about the best case and the worst case of the ROC curve, right, over there. So in the worst case, the curve is basically x equals to y, right? It's a straight line passing through the origin, right? So we will try to plot that one as well, so that when we'll plot our this curve, actual ROC curve, we'll see where our curve stands out compared to that particular line over there. Okay, so for that, what we'll do is we will generate some random numbers, okay, using numpy dot line space. So it's basically, then we'll plot this x as well, plt dot plot, okay, x against x, and we will try to give some separate color over here as well. Okay, so let's say color equals to light gray. Okay, now line style equals to, let's say we'll give this one, okay, comma, marker, let's say we'll not give anything over here, equals to 2, and also we'll give it a name, let's say label equals to, we'll just give the worst case, okay, worst case, so that we'll always try to understand where our ROC curve exists compared to worst case over here. Now you can give some legend font size as well over here, okay, size equals to, let's say 14 or 15 you can give. We will rename the x-axis x label, we'll give it a name called, let's say false positive rate, okay, and plot dot y label equals to true positive rate over here, okay, true positive rate. Also we will just try to give the x limit of and y limit of this plot as well over here, okay, 1, and plt dot y limit is equals to same scaling, okay. Now we will just do the plot dot show over here, okay. So this will basically draw the plot over here. So let's try to see the plot first, then we will see how we can calculate the AOC over here, okay. So if you see it over here, some error, line space missing, one required positional argument, stop, okay, yeah, we have to start from 0 and till 1. The values of will be generating is like from between 0 and 1 over here, okay. So as we are plotting the limit of this x and y axis of this plot is 0 to 1 over here. So let's clear the console and try to do that one, okay. It's label BEL over here, okay. I have done so many silly mistakes here, font size, okay. If you see it, like this is the worst case scenario curve over here, right, and our curve is showing up something like this one, okay, which is basically between the worst case and best case. In the best case, our curve should be going up and then going right side over here, right. So now if I just calculate the area under this curve, we basically will get a fair idea about how this particular logistic regression model is performing over here, a measurement of the performance over here, right. Now just like this ROC curve, the scalar dot matrices also includes a module called AUC, okay, AUC, by which we can basically generate this AUC score over here, the AUC measurement over here, okay. Now if you see the documentation of AUC, it requires two things, the APR and the TPR value over here, okay. So if I just print its AUC now, print the AUC, okay, and if I just say AUC of FPR and TPR over here, okay. So if I just run it now, let me just clear the console and run it. If you see, the current AUC score is 91115, right? Nearly 91% over here. Okay, so this is the AUC score for a single classifier. We have used it over here. Okay, now let us try to use a bagging classifier, which will basically an ensemble of, let's say, 500 logistic regression models, okay, and see how whether it is improving this model accuracy, or whether basically it is improving this AUC score or not over here. Okay, so for that, now we will be creating the bagging classifier now. So for that, first we will just search over here the bagging classifier. Okay, so BAGGING, bagging classifier. So if I just search over here, so here it is defined, right, under sklearn.ensemble.bagging classifier over here, right? So we will first import it. Okay, so we will import it over here. Now when you want to basically create an object of that particular classifier, you have to pass certain things over here, like the which estimator basically you want to use, because for all these different 500 estimators has to be the similar type, right, as we have seen in my PPT over there, right? So and then the how many estimator you want to use it over here, some random values over here. Okay, so that it will act as a seed for this bagging classifier to randomly picking up the samples from your training data set for training purpose over here. Okay, so we'll just copy it first. So this will be our bagging classifier over here. Okay, so bag classifier equals to this bagging classifier. Okay, now the estimator will be using it over here, our logistic regression. So we'll just copy this guy over here, so that we will be using this logistic regression over here, this one. The number of estimators we'll be using it today is 500 over there. Okay, so there will be total 500 logistic regression, which regression output which will be using for final estimation over here, the final prediction over here. Okay, and also let's not use random state over here. So there is a thing called OOB score, as I have discussed in my PPT as well, right? So you can use this one for each and every classifier. If you just want to test it out how this classifier is performing, you can use their OOB score as well, so that this particular bagging classifier will also generate the OOB score over here as well. Okay, now we have defined a object of that bagging classifier, right? We'll have to just fit it. So just like we did it for our logistic regression, we will be using the fit method over here, right? And what are the things we'll be passing it over here, as we have did it over here for the logistic regression, X train transformed and the Y train. So we'll be passing it over here. Okay, and if you just want to know the OOB score, you can print it something like this one. Print this bagging classifier dot OOB score underscore. Okay, so this you can use to generate the OOB score. Now similar way, when we did the prediction for the single one, we just did it something like this one, right? So predict, so in this case our model will be our bagging classifier over here, and we have to pass the transformed value of the X values, right? X test values basically. And similar way, if you want to generate the ROC values for this bagging classifier, right? So what we'll be doing it, so the probability val 1, let's say, okay, this bagging classifier, this one predict probability, the same data will be passing it over there as well. And in the ROC curve we will be passing this probability val 1 over here. Okay, now in similar way we did plot over here, right? So let us plot this one even let us try to print this precision score, accuracy score, and AUC values over here as well. Okay, so everything should be as is over here, because this FPR TPR will be getting new values based on whatever we have it over here for the bagging classifier, right? So basically this guy will be basically plotting the curve, the ROC curve, which is coming out of this bagging classifier over here, and this AUC score will be the AUC score for the bagging classifier, right? Now let us try to clear the console. So if everything we did correctly, we should be getting two curves over here, one for the single logistic regression model, another for the bagging classifier over here, right? Of the bagging of the logistic regression model over here. If you see it, the AUC score for the bagging classifier for the single model is around 0.9115, right? Now and the AUC score for this bagging classifier actually is slightly lesser than whatever we have it over here, right? So that means by using the ensemble of this particular logistic regression model, so 500 logistic regression models, actually not improving whatever we got for a single model over here. Now this could be the scenario as well, right? Not always ensemble will outperform the single model. It based on how the different classifiers over here is correcting the errors. That depends on how the bagging classifier or ensemble classifiers will be working over here. So basically, like this is the idea, the core idea behind this exercise is just to get an idea how bagging classifier works, and how compared to a single model a particular ensemble model works. Either it can work better if, let's say, instead of using a logistic regression, if we use some other kind of machine learning model, it may outperform the single model over here. So it's basically depends on how our experiment is and how it is coming out. Okay, so hopefully we got a fair idea about how bagging classifier works. Okay, and the idea behind how to create a bagging classifier in scikit-learn. Now if you want to make this one as a stacking algorithm, okay, so if I just go over here in the scikit-learn documentation, for the bagging classifier there is a input called bootstrap, okay, which is basically by default it is true. So if you just make this bootstrap, if you pass this guy over here, okay, to this bagging classifier as an input, something like this one, bootstrap is equals to false. Okay, so this will become a pasting algorithm. Okay, so pasting classifier over here. So that's the main difference between a bagging and pasting over here. Okay, so hopefully this video was helpful. In next video we will deep dive into some more other algorithms, ensemble learning algorithms. Okay, see you in next video.